Hello, this is MAT221, Calculus 1. This is Mrs. Johnson. We're in Unit 4, Section 2, talking about absolute extremes or extremes of a function. By the way, the local extremes are they also have a second name, just like absolutes are also called global extremes. Local extremes are sometimes called relative extremes. Now, I almost always say local extremes, but sometimes on WebAssign or on Google or other sites dealing with calculus, you might hear the word relative extreme, which is synonymous with local extremes. I want you to notice, as we were doing that last exercises, that the local extremes that are not at the endpoints, in other words, the local extremes that are on the interior of the function, are occurring where either the derivative is zero, as in this case and this case, or where the derivative does not exist, as in that second case. So notice I have horizontal tangent lines here, and here I have no derivative because of the cusp or the sharp corner that's on the curve. So local extreme values, if a function f of x has a local extreme or local maximum value or a local minimum value at the interior point of its domain, and if the derivative exists, then the derivative will be zero. Which brings us to the definition of a critical point. And we talked a little bit about this in Unit 2, but we're getting really more defined here in Unit 4 when we talk about the applications to the derivative. The definition of a critical point is any point in the domain of a function, f of x, at which the derivative is equal to zero or the derivative does not exist. This is called the critical point of the function. Now, why are they called critical points? Obviously, because the curve is either turning or changing in some way. So these are points that would definitely give us possibility for extremes. Note that the maximum and minimum points in the interior of a function, in other words, not at the endpoints, but in the inside of the function, in the inside of the interval domain, will always occur at critical points, either where the first derivative is equal to zero or where the first derivative is undefined. However, we have to be careful here. Just because we have a critical point does not always guarantee that I have a minimum or a maximum value. So let me say this again. If I have minimum or maximum values that are in the interior of a function, not at its endpoints, but at the interior of the function, they are always going to occur at critical points. However, be careful, because just because if I have a critical point does not necessarily always guarantee that I have a min or max. Let me give you an example of what I'm talking about. Critical points are not always extremes. Now remember the definition of a critical point is where the first derivative is equal to zero or does not exist. So if I look at this function, y equals x cubed, notice I have a derivative of 0 at x equals 0. F prime is equal to 0. Therefore, by definition, the definition of a critical point is when the first derivative is equal to 0. By definition, x equals 0 locates a critical point. However, this critical point is not an extreme. You can see that just by looking at the function. It is not the highest or lowest value on the function. So just because I have a critical point does not mean that I have an extreme. Let me give you another example. Y equals x to the 1/3, or the cube root of x. Notice the derivative is undefined or has a vertical tangent line at x equals 0. Therefore, the derivative does not exist. That's one of our 4 places where a derivative does not exist. So therefore, by definition, the definition of a critical point is where the first derivative is equal to 0 or does not exist. So by definition, x equals 0 locates a critical point, but this critical point is not an extreme. So there's 2 examples of just because I have a critical point does not necessarily make my value on the curve an extreme. However, if I have an extreme, they are going to occur either at critical points or at endpoints. So how do I find the absolute extremes of a function? Now this came from your textbook. This is a textbook example. If I said to you, find the absolute maximum and absolute minimum values of f of x equals x to the 2/3 on the closed interval from -2 to 3. Now, let's just go through a couple things that we just went through in this section of the chapter. I want to know the absolute maximum and the absolute minimum value. Remember, those are the output values of the function that are the highest and the lowest. And I have a function that is continuous. X to the 2/3 is a continuous function. And I have a closed interval. So the EVT, or the extreme values theorem, the EVT, is guaranteed here. I must have an absolute maximum and I must have an absolute minimum if I have a continuous function on a closed interval, which I have in place here. Therefore, I have to have my absolute extremes. So how do we find them? Using calculus. Well, we just said that extremes, if they're going to occur, are going to occur at critical points and endpoints. Those are the only places on the function I have to look. So what I do is I look at the function and I find its first derivative. Then I try to find the critical points. Critical points is when the first derivative is equal to 0 or does not exist. Well, this function, if I rewrite it, is equal to 2 over 3 cube root of x. This function, this derivative function, if you notice, a fraction will only be 0 if the numerator is 0 and the denominator is not. The numerator will never be 0 here, so the derivative will never equal 0. However, the derivative will not exist when the denominator is equal to 0. And that is also a critical point, because remember, critical points occur when the first derivative is equal to 0 or where the first derivative does not exist. So there are no values of x that will make the first derivative equal to 0. However, the first derivative will be undefined or will not exist at x equals 0. So the point on the curve when x equals 0, y equals 0, if you put in here into the original curve, 0, 0 will be a critical point. Now we're going to evaluate this critical point to determine whether it is a minimum or a maximum value. Because the function is defined over the closed interval, we also have to check the endpoints. So once I find my critical points and I know what the endpoints are, at this point all I have to do is take the critical point at x equals 0 and the endpoints and see what are the values of the function at these points. So in the domain from -2 to 3, at x equals 0, the value of the function is 0. All right, so 0, 0 is my first point that I need to look at. That is a critical point. Now we look at the endpoints. At x equals 2, the value of the function is the cube root of 4. At x equals 3, x equals -2, I'm sorry, I said 2. At x equals -2, the value of the function is cube root of -4, cube root of +4. At x equals 3, the value of the function is the cube root of 9. Okay, so what we did here was we found the critical point and then we found the value of the function at the critical point. There was only one critical point to look at. And then I looked at the endpoints and found the value of the function, notice f, at these points. Now what we're going to do is compare the three. Let's look at the output of the function. We have 0, we have the cube root of 4, we have the cube root of 9. Which of these three outputs is the highest? Well, obviously the cube root of 9 is the highest. It is a higher number than the cube root of 4. So of the three values that we look at, the output that gives us the highest value is my absolute maximum. Look at the three values and say which of the three values is the lowest. Well, the lowest is here at x equals 0, so this would be my global minimum. So in this function, f of x equals x to the 2/3 on the closed interval from -2 to 3, the cube root of 9 is the global maximum occurring at x equals 3, and 0 is the global minimum occurring at x equals 0. I've now found the global extremes, or the absolute extremes, of this function. Now we could have put this on our calculator to figure out these values, but you can just definitely see the cube root of 4 is going to be lower than the cube root of 9 because 9 is a bigger number than 4. So we really didn't even need our calculator to determine that. So to determine if this critical point is actual minimum or maximum, we try the points on either side without passing the critical point. And we also look at what is the highest output of my endpoints. Since 0 is less than 1, this must be at least a local minimum and possibly a global maximum, right? Value here, global minimum. So the absolute minimum was 0, occurring at 0. The absolute maximum was the cube root of 9, which is about 2.08, occurring at x equals 3. Now, if we graph this on Mathematica or on a calculator, you can definitely see the curve. So we're only looking at the curve from -2 to 3, so I only looked at that curve in this point. You can see that the absolute minimum occurs here at 0, and the absolute maximum occurs here at x equals 3. So what was our procedure to going through to find the global extremes or finding the minimum and maximum values analytically? Well, here was our steps. First, we find the derivative of the function and determine where the derivative is equal to 0 or where the derivative is undefined. In other words, we are finding the critical points of the function. Remember, that's the definition of a critical point, where the derivative is equal to 0 or where the derivative is undefined. Secondly, we find the value of the function at each critical point. Next, we find the values of the function at the endpoints of the interval because minimums and maximums will only occur at two places, either at either at critical points or at endpoints. And then lastly, we simply substitute the values of the critical point and the values of the function at the endpoints into the original function, and whichever one of these is the highest value, that will be our absolute maximum. Whichever one of these gives us the lowest output value, that gives us our absolute minimum. And remember, we're looking at the output values of the function. All right, this concludes section 4.2's PowerPoint. But I will put up a couple more videos going through some of the worksheets that we have in the worksheet folder in Unit 4 so that you guys can work on a couple more of these and work on your WebAssign. Have a great week.